The Troublemaker Solid is going to be a solid option for no-thumb bowlers and thumb-in players alike. Hey team, welcome back to the channel, welcome to 2025, and welcome back to my cold opens. My name is Brian Buckosh, core design engineer with Brunswick Bowling, and today we're taking a look at the brand new Troublemaker Solid in the DV8 lineup. Now, normally with a core that has been in the lineup before that's getting a cover stock refresh, I would be doing a 1-minute review on my Shorts tab on YouTube. But because the Troublemaker has so much going on with this Dualistic core, with this patent pending no thumb core design, and with the layout process, I wanted to make sure that I gave it a little more detail in a long form video that pro shop operators will appreciate. We've got some brand new resources on the DV8 bowling website that I want to highlight for you guys, including some after drilling numbers so you guys can dial in the exact motion shape that you're looking for when you're putting layouts on these balls. So we're going to dive right into it. Now, the Troublemaker has been in the lineup. This is the third iteration now, so I'm not going to spend quite as much time going around this core and explaining all the details. But if you're interested, I had a 3-part series when the original Troublemaker Hybrid came out back in 2022, and again some information with the Troublemaker Pearl. So look for those videos on my page if you want more in-depth analysis. But we're going to take a look at this Dualistic core as a refresher one more time. This core has loosely a 250 RG with an 045 total differential before you drill into it, but of course this one is built with very functional core shape to make sure that you get the widest range of drilling options after drilling when you put your fingers in specific locations into this core. For example, this core has a top knob. When you drill your fingers 2.5 inches from the dot to the center of grip or closer to the dot, then your fingers are going to drive right into the top of this top knob. It's effectively shortening the core and reducing the differential. We'll get into all the numbers in a little bit here, but it also has this functional void. The bowl of the core is what we've been calling it in nicknaming, and this is the range between 2.5 inches and 3.5 inches from the dot to the center of the grip. When you drill your fingers in that range, what it does is it misses most of the inner core and drills out the compound material instead. What this does is it leaves most of the inner core intact, and you get numbers that are relatively close to the pre-drilled numbers, around 0.45 total differential, with very little change in asymmetry to this core. And of course, if you want to make this ball very strong, you can drill into the side of it. So if you choose a dot to center of grip distance that is greater than 3.5 inches from the dot to the center of the fingers, which is your bridge center, then you're going to hit the side of this core very readily because of how close it is to the shell. You're going to blow up the total differential by making this core taller and skinnier relatively, and you're going to blow up the intermediate differential by making this core more of an ellipse. What this does is adds asymmetry, and this core can be as asymmetric as 18 points of intermediate differential, even with just 2 fingers in the ball. So coming from 0 asymmetry before drilling, that is a substantial change. And just for reference, a standard core without this type of technology will usually achieve about 8 to 10 points of intermediate differential at the most for the strongest layouts for a symmetrical ball after drilling. So to achieve 18 points after drilling is a substantial change, and it gives you more of an asymmetric motion after drilling. So you can pick a dot to center of grip distance that's anywhere in this range from 1.5 inches to 5.5 inches basically to dial in the performance that you're looking for total differential and intermediate differential. And speaking of that, we've got a number of resources on DV8's website to walk you through this so that you're not doing any guesswork. From the homepage, you're going to go to the products drop-down menu, go to balls, and then go to no thumb resources. From here, you'll be greeted with a blurb about the technology, and here are the cross sections of the 2 cores. We've got our Troublemaker standard core for 14 to 16 pounds, and you'll notice that we also developed a lightweight core that is just a smaller volume, thinned down version of the same core in 12 and 13 pounds so that young up-and-coming two-handed bowlers can take advantage of the exact same technology. If you scroll a little further, you're going to see 3 downloadable links. The first one is our dual angle converter. This takes all the components of no-thumb layout systems and converts them into simple dual angles that almost every pro shop operator already knows how to use. It will download as a standard Excel sheet. You can open this on your desktop, on a tablet, or on your phone. Sometimes with the mobile and tablet options, there are some nuances about the display that have been a little funny for us. So if you have any questions, feel free to drop a comment below or message me on my Bowling Buckosh Facebook page. We can get those cleared up for you. But for most people running Google Sheets, Excel, they haven't had too many issues. They've been able to input the values and get the right dual angles back out of the spreadsheet, no problem. So we're going to come back to that spreadsheet and do a walk around in a minute, but the next thing I want to show you is that there are two dot to center of grip distance guides. They have the exact same information on them, so don't worry too much about which one you're picking. The only difference is the display images on these dot to center of grip distance guides are just a little different. They're more accurate to the asymmetric heckler core on the asymmetric guide and the symmetric troublemaker core for the symmetric dot to center of grip distance guide, but the information about the distance is the exact same. And the final link you'll see here is the link to download the after drilling numbers for all of our no-thumb cores. Right now we have the unholy core, which is in the heckler series with asymmetry, and we have the dualistic core that's here in our troublemaker solid. So let's take a look at all of these resources one by one. And we're going to start right here with our dot to center of grip distance guide. You'll notice that, as I described before, we have all of our recommended distances, 1.5 inches to 5.5 inches. The shortest distances are built for control, reducing flare potential, and does not add any asymmetry to this core. At 1.5 inches dot to center of grip, that's going to be a dot to center of grip distance that we're only recommending for highly rev dominant players or extreme high friction environments. Typically speaking, the range for most players is going to be in the range from 2.5 inches to 4.5 inches from the dot to the center of grip. As you go up in dot to center of grip distance, then you're also going up in total flare potential because you're increasing the ball's ability to have post-drill differential. And as you get into the extremely long layouts, like 4.5 inches dot to center of grip around the side of the ball and 5.5 inches dot to center of grip around the side of the ball, then you're also adding asymmetry to the core for an even shorter hook window. So you're adding flare potential and you're adding hook with these long distances. You're reducing flare potential and you're reducing hook with the short distances. It's a very simple, self-explanatory system, so you can always download this guide, pin it to your wall, or keep it saved in a file on your phone. Pop it open if you're a pro shop operator and have a quick reference guide that you can always come back to in case you need a reference to remind yourself exactly what distance you want to pick to dial in the motion that you're looking for the player. The next resource I want to point out for you is the post-drilled values guide. This is a new chart that we just built for the release of the troublemaker solid, and it's got two columns, one for the heckler core and one for the troublemaker core. Those are the two cores currently for the no-thumb lineup. The first row is going to be your undrilled values. That's before you put the holes in it. And now we've got our dot to center of grip distances as a reference. And this is the exact dot to center of grip distances that were on the sheet that we just looked at. We have a handy little picture that kind of gives you a generic look at what the after drilled fingers are going to be once placed into the bowling ball. And they coincide to the exact distance from the center of the grip to the dot. So we'll take a look at the second column for the dualistic core that's in the troublemaker, since that's what this video is about. Undrilled, this ball is basically a 250 RG with an 0.45 differential, no asymmetry before drilling. If you choose 1.5 inches dot to the center of grip, then after drilling, you're going to be in 251 range. The RGs don't change very much, so I won't be talking too much about them. But notice that you've drilled 10 points of differential out of this core, which means that you're left with 0.35 total differential, and we've made very, very little asymmetry in this core. It's effectively an extremely symmetrical ball still after drilling. So at 0.35, this is going to be tighter flare spacing and basically a tour style control ball for you. And let's take a look at the other extreme example. If we decided to put our fingers all the way around the side of the ball at 5.5 inches from the dot to the center of grip, after drilling you're left with a 2499 RG, effectively 2.50. Those don't change very much. But look at how the total differential has blown up to 0.58. What a change in total differential. And the intermediate differential was once 0, went to 3 with our 1.5 dot to center of grip distance, is now blown up to 18 points of intermediate differential after drilling. That is squarely in the asymmetrical range of ball motion. So a huge change there. That would be considered a strong mid-lane layout for this Troublemaker solid. And of course, pairing it with this strong sanded solid Havoc cover stock, that is going to be very early, very diggy, and a very abrupt mid-lane motion. So somewhere in the middle is, again, where we recommend that most players reside. If you want slightly more control for someone like a rev dominant player or lighter oil volumes, then 2.5 inch dot to center of grip is perfect for getting a smooth benchmark motion. And if you have a slightly speed dominant no thumb bowler, then we recommend in the range 3.5 to 4.5 inches. And one of those two is going to get you a slightly stronger yet still smooth reaction in this Troublemaker solid. And if you go 4.5 inches, then you're going to have a little more change of direction in the late mid lane, the back of the lane, because you've added asymmetry. So it's going to shorten the hook window and make this one a little more abrupt. You can get in and swing it and expect that it gets back a little harder. One interesting thing I want to note about this post-drilled chart is that we have not made mention of the DOT to PAP distance at all. And that's really interesting because what happens when you change the DOT to PAP is you're changing the rotation of the core relative to the PAP. Or in other words, you're changing the core angle for the first rev off the bowler's hand. Changing the pin to PAP or the dot to PAP distance rotates the core in position, but it doesn't change where the mass is being removed, and therefore it doesn't change the post-drill differential numbers. So that's really interesting. What it will do is it will change the motion because you're changing the way that the core angle sits. So even though the numbers are the same, the motion through the hook and the roll phases are going to be different for the different pin to PAP positions, dot to PAP positions. So that is still an incredibly important component of the layout, but we haven't mentioned it here in the chart because it doesn't change the numbers all that drastically. So what we are recommending is that you pair these specific dot to center of grip distances with the bowler's favorite or benchmark PAP, pin to PAP or dot to PAP. Now, what that's going to do is allow the chosen dot to center of grip distance to kind of shine and be the thing that's changing the ball motion the most. So circling back around now, the first thing that we downloaded and the last thing that we're going to talk about is the dual angle converter. If you've watched my previous videos, then you're intimately familiar with this converter by now, but if you haven't, I'm going to give you a quick walk around. It's very simple. When you open this up, it's a pretty standard Excel sheet or whatever spreadsheet program that you're running. And excuse the clicks, you're going to hear them here. I don't have a very quiet mouse. First thing that it's going to ask you is the inputs at the top. You need to know the bowler's horizontal and vertical PAP coordinate. And then we're going to get into the layout specifics that's going to output your dual angle layouts. So we're going to use two examples here. The first one I'm going to do is a short over and a tall up coordinate. So for example, if this bowler is 3.5 inches over and has a 2-inch vertical coordinate, then we're just going to input those two values in the spreadsheet. Next, we're going to go to the ball layout. For the Troublemaker, we're going to use the symmetrical system. Now notice that it blacks out the ability to choose a drilling angle for you because automatically our system points the CG toward the center of the grip in the layout no matter what. In some cases, such as when the horizontal coordinate is further over, you will get cases where the drilling angle output is over 90 degrees, and that's okay. We've had cases where the drilling angle is as high as 148 degrees as a random example. And all that's doing is we're just making sure that the core is forward facing in the layout. In other words, that the CG is pointed at the center of grip, which is the center of the fingers in this case. So if you see an arbitrary long angle as the drilling angle on a symmetrical ball, never fear, that is exactly what it's supposed to be. Apply it to the ball, and as a check for reference, you can make sure that the CG is lining up on the line between the dot and the center of the grip. Now that we've selected our symmetrical option, we're going to input the two things that we need to complete our layout. First is pin to PAP or dot to PAP. Our professional staff has had really good luck with pin to PAP positions in the range of 5 inches, so I'm going to go ahead and input 5 in this box. And for the dot to center of grip or the pin to center of grip distance, you're simply going to choose one of the 5 recommended options. We actually have them in half-inch increments here for you. And for whatever reason, when I do screen recording, the drop-down menu doesn't show, but I have a drop-down menu here that goes from 1 inch all the way up to 6 inches as your options for your dot to center of grip distance in half-inch increments. Of course, we're recommending 1.5 inches all the way up to 5.5 inches, and for the most benchmark layouts, you're going to want to stick right in the middle. So for this example, let's just pick 3.5. That's squarely in the middle of our range. So this is a very benchmark style layout for a person who has a very short over and very tall up coordinate. The next category is just some checks to be sure that your layout is both valid and is applicable to the ball. What you need to know about these 2 boxes is that the layout sum at the bottom is just basically totaling the 2 values that you've just picked. 5-inch pin to PAP and a 3.5-inch dot to center of grip distance is going to sum to 8.5. As long as that total, 8.5 in this case, is higher than the COG to the PAP distance, or that straight line from the fingers to the PAP basically is what that number is calculating, then if that layout sum is bigger, and the layout is good, it's valid, it's possible to draw on the ball. And since everything is going well, all the boxes are populated with numbers, and we have our dual angle converted at the bottom for you. So this is very simple dual angles. The first angle, drilling angle, 59 degrees. The pin to PAP distance is just translated down from what you input earlier, 5 inches. And the VAL angle is 61 degrees. You'll notice that these dual angles are very specific. That's because they're calculating very specific locations. In the example of the drilling angle, that 59 degrees is the exact number that is required to point the CG directly at the center of the grip for this specific PAP. And that VAL angle, 61 degrees, is the exact VAL angle that's required to get that dot to be exactly 3.5 inches in this case from the pin to the center of grip. So if you use those angles exactly as they're listed, then you should be able to put your prosect on the final layout once you've put it on the ball and verify, yes, 61 degrees was exactly 3.5 inches from the pin to the PAP, and yes, the CG is in line with the fingers. And just for an example to show you how the numbers change for different PAPs, what we're going to do here is we're going to leave the exact same layout, 5 inches pin to PAP, 3.5 inches dot to center of grip, and we're just going to change to a different bowler. Let's say this bowler has a long over coordinate, we're going to use 6 inches, and they have a down coordinate. So in this case, down, when we're inputting the vertical coordinate, has to be a negative number. In this case, we'll just use -2 here. So at 6 over and 2 down, the same symmetrical layout, the same 5-inch dot to PAP, the same 3.5-inch dot to center of grip distance, we get vastly different dual angles as the output. 100 degrees drilling angle is required to get the CG back over toward the center of grip. 5 inches pin to PAP is the same 5 inches that we picked above. Now the VAL angle, 39 degrees, has changed pretty substantially from that previous number to get the pin up. Remember, when you have a down coordinate, you're probably going to need sharper, smaller VAL angles to get the pin up where it belongs. So I hope that highlighted why we designed this converter for you. Interestingly, it is the dot to the center of grip distance in inches that is going to control the total flare potential and the motion response of this ball. So the VAL angles are going to vary wildly depending on the bowler's PAP. It's really imperative that you measure the bowler's PAP, have an accurate measurement before you try to apply this system, of course, and that's the same with every system. You can't use dual angles without the bowler's PAP, you can't use the storm systems without the bowler's PAP, the PAL system. Every system to lay out a bowling ball is dependent on knowing the bowler's specs ahead of time. So if you're a bowler and you don't have those specs, make sure you find a reputable pro shop that has them. And if you're a pro shop operator, just make sure you're taking the time to double check your customer's specs. It is going to be worth it in the long run to get the most out of the equipment that they're buying from you. Alright, I know that video got a little longer than I intended it to be, but isn't that how it always goes for me? We have a lot of new technology, and I just want to make sure that you guys have the most resources to understand how they work. And honestly, with the combined resources, you should be able to kind of get used to the system, get in the rhythm of it, and it shouldn't take you more than an additional 30 seconds to kind of pick your layout for the player, apply the conversion, and then just draw the dual angles on the ball just like you always would for every layout. So really, this additional step of checking the dot to center of grip distance and then converting it to dual angles is all that we're introducing for you. There's only one new variable. Of course, if you're drilling an asymmetrical ball, we allow you the option to pick your drilling angle just like you would in the standard dual angle system. And just like in the dual angle system, that works to control how fast the ball revs up. So nothing new here. The pin to PAP distance and the drilling angle function just like they always would. And we're just giving you this new bit of information, which is the dot to center of grip distance, the pin to center of grip distance. And we're giving you this converter to make it convenient for you to apply dual angles to the ball, since that's the quickest and easiest system to apply to the geometry of a sphere. I know I didn't talk too much about the Troublemaker Solid, but I just wanted to make sure that everyone has access to these resources. The new Havoc Solid cover stock that is on the Troublemaker Solid, of course, is going to be a step up, a step smoother, and a step more aggressive than the original Troublemaker, which makes it basically 2 balls up in the symmetrical category from a Troublemaker Pearl. If you have any questions about the ball motion itself, which I didn't get into too much detail about, any questions about your personal arsenal, or any questions about any ball in the DV8 lineup, feel free to drop a comment below. I'm happy to respond when I have time. Make sure you're following me on Facebook or on YouTube, wherever you get your social media content, because I make new videos whenever there's a new core out for the brands of Brunswick. And if there is a new ball out that doesn't get a new core but a refreshed cover stock on top of a core that already exists, then of course I'll be on my Shorts tab on YouTube giving you 1-minute reviews about the new cover stocks. Again, if you have any questions, feel free to drop them below, and I will see you in the next video.